Ever feel like we're living in this like cosmic puzzle box? Like seriously, what is it all about?
Well, there might be no better place to look for answers than the Large Hadron Collider.
Yeah, the LHC. It's like what is this, a 17-mile long racetrack for protons
Underground, right.
and spanning 2 countries?
Buried hundreds of feet underground, in fact. And yes, a global effort for sure.
So those sources we dug into this week, they get into all the cool details about it. So let's dive in, huh?
Absolutely. So maybe more than just smashing things together at super high speeds.
Which is already kind of a wild thought when you
Yeah.
really...
Right. Well, it's about recreating conditions that existed just fractions of a second after the Big Bang.
Whoa. Okay, so we're talking like really tiny glimpses into the universe's first moments.
Exactly.
To do that, though, I imagine you need some seriously next-level tech, right? You're not wrong.
The sources mention something about superconducting magnets.
Ah, yes. Now, picture this. A magnet so powerful it has to be colder than outer space to even function.
Wait, seriously?
Oh, yeah. We're talking magnets, some of them weighing as much as a jumbo jet, chilled to almost absolute zero.
Just so they can, what, conduct electricity without resistance?
That's the key. Zero resistance means we can create crazy strong magnetic fields to steer and focus those proton beams.
So not your average fridge magnet then? And we do all this to smash together things we can't even see. Why?
Because sometimes those tiniest things hold the answers to the biggest questions.
Okay, I'm listening.
Take the Higgs boson. Discovered thanks to the LHC, this thing is why everything has mass.
Hold up. The Higgs boson gives everything mass. Without it, everything would basically be massless energy, just zipping around at the speed of light.
Whoa. So no Higgs boson, no us, no planets, stars.
You got it. It's all thanks to the Higgs boson interacting with other particles, giving them inertia,
Inertia meaning.
mass. Before they found it at the LHC, it was like this missing link in our understanding of, well, everything.
So the LHC found the key to, like, the fundamental forces of the universe.
You could say that, but it doesn't stop there.
Oh, there's more.
The LHC is also helping us probe into this thing called dark matter. It's this mysterious stuff, actually.
Stuff.
Yeah, we can't see it directly, but we can tell it's out there. It's like it makes up a huge chunk of the universe.
Wait, so most of the universe is made of something we can't even see.
Pretty much. We only know it's there because of its gravity. It affects the stuff we can see.
So how do we figure out what this dark matter actually is?
That's where the LHC comes in, by smashing particles together at these crazy high energies.
You're hoping to actually create dark matter.
We're trying to create and detect the particles that make up dark matter. We're talking about finally shining a light, so to speak, on this mysterious stuff.
That's kind of wild to think about, you know? This thing is built to help us see what we can't. But it creates so much data itself. It's like...
Trying to find a needle in a haystack of hard drives.
Exactly. The sources called it a monumental task, and like, they weren't kidding. How much data are we even talking about here?
Think of it this way. Every year, the LHC generates enough data to fill a stack of DVDs that would reach to the moon.
Every year. Seriously?
Seriously, it's an insane amount of information.
Okay, so we have this massive machine smashing atoms, generating mountains of data. How do you even begin to analyze all of that?
Well, it takes a global network, right? Like supercomputers all over the world working together.
To crunch those numbers, find the patterns.
Exactly. They're looking for the tiniest anomalies, the faintest hints of something new.
And that takes a lot of people too, I bet.
Thousands of scientists and engineers all around the globe working in collaboration.
It's like this huge team effort to understand the universe.
It really is.
Though it sounds like it hasn't always been smooth sailing. The sources mentioned something about an incident back in 2008.
Ah, yes. It was a stark reminder that even with all the planning, all the precautions, things can still go wrong, especially when you're working at that scale, at those extremes.
And what happened exactly? The sources mentioned something about a helium leak.
That's right. There's a faulty electrical connection which caused a massive leak of liquid helium.
And that's bad because...
Well, liquid helium is what keeps those superconducting magnets at their ultra-low temperature.
Right, because they have to be colder than space to work.
Exactly. So this leak, it caused significant damage to a section of the accelerator.
Oh, wow. How significant are we talking?
They had to put the entire project on hold for over a year to make repairs.
A whole year? That's a pretty major setback.
It was a major setback, no doubt. But it also shows how resilient this whole endeavor is.
No, so
Well, they didn't just fix the leak and call it a day. They used that incident as an opportunity to learn and improve.
So they came back stronger,
Yeah.
smarter.
They implemented new safety protocols, improved the monitoring systems. It was a really valuable learning experience, and it continues to inform how they operate the LHC today.
Like sometimes you have to break a few things to figure out how to really make things work, you know?
Something like that. It's about constantly pushing the boundaries of what we know and what we can do.
And speaking of pushing boundaries, the sources also mentioned this upgrade, the High-Luminosity LHC. What's that all about?
It's basically like giving the LHC a major power boost. It'll increase the number of particle collisions significantly.
So even more data to sift through.
Way more data, but also more opportunities to see rare phenomena to potentially discover things we haven't even imagined yet.
Okay, so more power, more data, more potential for groundbreaking discoveries. Sounds exciting. So more power, more data, more potential for groundbreaking discoveries. What's on the top of the list for this high-luminosity LHC?
Well, there's this theory supersymmetry that's been floating around for a while. It suggests that every particle we know of has a sort of super partner with like a secret twin, but with different properties.
So like a whole other set of particles we haven't even found yet.
Exactly. It'd be like a whole other level of reality hidden right beneath what we can see.
No, that's just cool. And if we find these super partners, what then?
It could change everything about how we understand the universe. For one, it might help us finally nail down this whole dark matter thing.
Oh, right, because we were just talking about that. So supersymmetry might be the key to finally understanding what dark matter is made of.
It's definitely a possibility. And beyond dark matter, it could help us understand the fundamental forces of the universe in a whole new light.
So the LHC is like this tool that's letting us peer deeper and deeper into the fabric of reality. It's pretty mind-blowing when you think about it.
It really is. And the high luminosity LHC is going to take that to a whole new level. We're talking about studying the Higgs boson in way more detail, potentially even uncovering new particles and forces we haven't even dreamed of yet.
So even with everything the LHC has already accomplished, it feels like we're still just scratching the surface.
Exactly. There's so much more to discover out there. And the amazing thing is, the more we learn, the more we realize how much we don't know.
That's the best part about these deep dives, right? There's always something new to learn and explore. Speaking of which, the sources mentioned a future collider even bigger than the LHC.
The Future Circular Collider. Now, that is a seriously ambitious project.
Okay, so how ambitious are we talking? Give me the details.
Imagine a collider nearly 4 times larger than the LHC, capable of colliding particles with 10 times the energy.
4 times larger. That's just, wow, what would we even hope to achieve with that kind of power?
We're talking about probing the most extreme conditions in the universe, recreating the energy levels present just moments after the Big Bang.
So even closer to the very beginning of, well, everything.
The FCC could help us find answers to questions we haven't even thought to ask yet. It has the potential to revolutionize our understanding of physics and cosmology.
From a 17-mile racetrack to,
Yeah.
well, whatever massive engineering marvel they come up with next. It's incredible to think about the dedication, the collaboration, the sheer human ingenuity driving all of this.
It really is a testament to our desire to understand the universe, to unravel its mysteries.
Absolutely. And on that note, I think it's time to wrap up this deep dive into the heart of matter. We've gone from smashing atoms to pondering the fate of the universe, and honestly, I'm feeling that sense of wonder, like when you were a kid looking up at the stars, you know. If this deep dive has taught us anything, it's that the universe is full of surprises. And with every new discovery, with every answer we find, we open the door to even more mysteries, more questions, more possibilities. And who knows? Maybe someday, thanks to the incredible work being done at places like the LHC, we'll finally unlock the secrets of the cosmos.